Hi, so today I'm going to be going over an 820-2936 board that had no power on it. I'm going to go over a little bit of the troubleshooting process of what I did, why I did it, and what I found. So the problem I was having with this board is that when you plug in the charger you get no green light, and in addition to getting no green light on this one, you were also getting no power anywhere. So sometimes you plug this in and you get no green light, and that's common. As I said in the other videos, there's something called the one-wire circuit that very frequently goes bad and very frequently causes it to not charge or do anything. And right now, since I'm on camera, it's also deciding to not charge or do anything. Lovely. Ohs. And here it goes. So see, as I said, everything that I do in a video does not work. So as you can see, I have a green light, it's charging and the fan is spinning, and about 10 seconds ago it wasn't doing that just because I wanted to show you that it worked. So when I say no power versus just no green light, here's what I mean. I mean when I measure PP bus G3 hot, which is the power that gets sent to the rest of the machine, pretty much the power that the entire machine runs off of, I got nothing. So let me just zoom in a little here so you can see what I'm talking about. So you're right over here on F7040, which is not anti-aliased because I'm trying to record HD video while anti-aliasing a PDF file on a laptop. You get the 12 volts that the system is supposed to run off of. It's actually more like 12.6 volts in this case. So let's do this, and let's do this, and yeah, my PDF reader is really not feeling that whole recording HD video while zooming in on PDFs thing. My laptop is not liking that. So you'll just have to live with the fact that this looks jagged unless you just want to donate me another computer to do these videos. So here's F7040 on the schematic. This is where the ISL 6259, so right here you have the ISL 6259. Let's just zoom in a little bit here. So this is the ISL 6259. This pretty much takes the power from the charger, and it takes this power from the charger, and then it controls these two transistors here, which take power from the charger and bring it here, and then pretty much this shorts to ground. So right over here, where it says charger phase, you have these two transistors creating a bunch of little pulses of current. So let me show you what that looks like here on the oscilloscope. Alrighty. This is where this thing is cool, is in being able to do the demonstrations. So in my upper left corner you have an oscilloscope, and watch what happens when I put it over right in front of where that is. So right over here, I'm going to put it right over here. Okay, now you see that clusterfuck up there in the oscilloscope? Here, let me just move the scale over so you can see it. It's a bunch of pulses. What you see here are a bunch of pulses, and these pulses are at around 15 volts, right? With the going up, down, up, down. The average voltage is 15, but it is actually much higher than that for a decent period. So what this is doing is it's pretty much taking the charger, and it's taking these 17 or the 18 volts from the charger and just saying 18, nothing, 18, nothing, 18, nothing. Now, the way that what this is doing is over here is actually ground. So let me zoom back in over here so you can see the circuit. So what you have over here are these two transistors, and they're controlled by the ISL 6259. So as I said, a transistor is pretty much a variable resistor. So it's a resistor whose value can change based on what you tell it to do. So the resistance between the charger and over here, and the resistance between over here and ground changes based on this input signal. So every time this gets shorted to ground while this is opening, you pretty much have a pulse of electricity. So this is ground. Electricity likes to go to ground. So when this opens and this opens, you have a little pulse of electricity over here. Now, this is pretty much useless. Like again, as I said, switching power supplies are lazy pieces of shit. Switching power supplies do not actually create power. What they do is they create a bunch of little pulses and say to the system, you know, fuck you, now if you want that to be something usable, you have to do that yourself. And that's what this inductor is for. So see what happens when I measure after the inductor? I get that very, very nice clean 12.8 volts, a nice straight line across the oscilloscope. That's right over here on this circuit. So let me just make sure I'm still recording since I don't trust this system one bit. Okay, it looks like still recording. By the way, this is the first video I'm doing with a different video compression system, so hopefully I'm able to actually not fill up my drive every time I record. The reason I don't record directly to the SD card in the camera is because it would be a pain in the ass to edit in real time. If I'm doing something with the microscope, I wouldn't be able to have it. I wouldn't be able to have it in sync, and it would just be a royal pain in the ass. So I just record both streams at the same time directly to the laptop. But anyway, so this is that inductor over here, L7030. And right after that inductor, you have this fuse, which is really easy to see on the board. It's this big white thing over here. Yeah, see what I'm pointing to, the big white fuse? So when you measure on there, I was getting something like 0.2 volts. Now when the one-wire circuit is messed up, a lot of the times the one-wire circuit, which is the circuit that tells the machine that the charger is connected, is messed up. At the very least, this chip is doing its job, and I'm getting 12.6 volts here. Here it was so fucked up that I wasn't even getting that 12.6 volts there. So let me show you what I mean about the one-wire circuit, and I want these videos to be something where you can actually learn without having to go through every other one. So I'll just for the hell of it, I'm going to show you the one-wire circuit again, and I feel like I'm going to be talking about this in a lot of these videos. The one-wire circuit is the circuit that tells the system that the charger works and that you can use it. And I'm going to go over this briefly. Again, if you want a real full explanation of it, you can go over any one of the other fucking videos where I go over this. Right here is the adapter. So this is the MagSafe. So you see over here it says Adapter Sense. Adapter Sense, it goes to this chip over here, which shoots out something called Sys1 wire. This has an input called SMC BC ACOC VCC. Now this is going to be kind of confusing in the beginning, but just give it a minute. Now over here you have SMC BC ACOC and 3.42 volts. The whole way this system works, let's try to keep it as simple as possible. When this chip has this signal from here, this SMC BC ACOC signal, and this adapter sense signal, it sends out this Sys1 wire signal that tells the computer you can now give a green light to the charger, and the green light is what we want. So to keep it simple, adapter sense over here. Once you have adapter sense, once it senses that this MagSafe connector is plugged in, and it has this signal called SMC BC ACOC coming from the other section of the board, which I'm going to show you in a second, it sends out Sys1 wire, which says turn on. And one of the very common faults in the older of these boards, since this chip was right next to the edge of the computer where water gets in, is that 3.42 volts is not there. And I measured there was 3.42 volts there. My adapter sense was getting there from the adapter. What was missing was SMC BC ACOC. When SMC BC ACOC is missing, it suggests a problem with another part of the machine. Let's take a look at the other part of the machine. So now you may wonder, where does SMC BC ACOC come from? As you can see, I literally hit Control F, I typed it in, and now it shows me. So this is the ISL6259 part of the circuit. There was no SMC BC ACOC coming from here. One of the things I do when I don't have SMC BC ACOC is I measure around this chip. So there are a couple of things that need to be proper in order for me to get a green light, and in order for this signal to shoot out to the one-wire circuit to tell it to turn the fuck on. Again, my one-wire circuit needs two things to be true. The first thing it needs is for an adapter to be connected. The second thing it needs is to have this SMC BC ACOC sent to it. So I'm not getting this. I have adapter sense. The 3.42 volts was on that chip that I showed you, so I did have 3.42 volts present. But what I didn't have is SMC BC ACOC. So one of the things that often goes wrong is this little charger AC in thing over here. So charger AC in is fed by this voltage divider. A voltage divider is a series of resistors that take a higher voltage and turn it into a lower voltage. They're not very efficient at what they do, but it's a very quick, simple, and cheap way to turn, 16 volts of system power or 12 volts of system power into 3 volts or 4 volts if for whatever reason you need to make a signal really quick. So that's what this does. And again, it's probably like a 5-cent way for Apple to make the signal. So you have from adapter, so from the adapter, from that 16 or 18 volts from your adapter, you have these two resistors, a 30 kilo ohm resistor and a 9.3 kilo ohm resistor. One of these resistors is going here. This other resistor is going to ground. If you don't know what a voltage divider is, you pretty much have a resistor going from your source voltage to your destination, and then from your destination to ground. And the value of these resistors, or the proportion to one another, is going to set what the power is. So here, these two resistors are set up in a configuration so that you get 4 volts out of the charger voltage. So you start out with the charger voltage, and then you turn into something like 4 volts over here. So I had 4 volts over here. That worked. Now, the other thing to check is the current sensing part of the circuit, and I was actually a complete fucking idiot with a different board about 1 day ago because I missed a very, very basic part of a charging circuit. That was damn embarrassing. But right over here is something called the current sensing circuit. The whole way that this works is this machine cannot sense how much current is being used. This chip cannot sense current. What it can measure is voltage. So what it does is it tries to measure the voltage drop across a certain point and then estimate what the current use or what the power usage of the system is. And if it notices that the charger has too much current going through it, it turns it off so that the charger doesn't go on fire and light your house on fire. So the whole way this works is this is the charging voltage right here, right? It goes through this resistor, which is 0.02 ohms. That's nothing. That seriously, that is absolutely nothing worth thinking about. That's a joke. But it's going to cause a very, very, very small, barely noticeable, tiny little drop in power. And that little drop is going to what this does here is before the resistor and after the resistor, you have these two traces that go to these resistors that then go to the ISL 6259. So before this resistor and after this resistor, it measures the power at those points. And by doing whatever kind of math and funky shit whatever this chip does, after measuring the beginning and the end of this resistor, it knows how much power your charger is using. And once it knows how much power your charger is using, it knows whether or not it should turn it off based on however the hell Intersil designed that chip. I'm not going to get into the design of those chips because that is way over my head. That's for people who pass chemistry in college. But the whole point is, everything there measured all right. So I'm good. And again, even if these resistors measure okay, you should measure the trace from here to here. You should measure the trace from here to here to make sure that it's actually going where it's going. It doesn't matter that the resistor is good if what's feeding it or what it is feeding in front of it is not actually there. So that's a good thing to do. I measured all this and it was good. And I didn't have a flickering light on the charger. Sometimes you have a flickering light on the charger if any of these capacitors in the area are bad or, everything there was just fine and dandy. So what I figured is that something else must be wrong here because I'm only getting 1 volt in the charger and I don't have my SMC BCA cock. And I have everything I'm supposed to have in order to have a green light. So one of the things I'm now interested in is there a short to ground? Now, right over here, if one of these transistors died, or if anything that's running on the system power on that PP bus G3 hot voltage, that's what this is called, by the way. So after it makes that 12.6 volts, it's called PP bus G3 hot. If anything running on that is fucked or shorted to ground, if anything has died at all, that entire voltage will get shorted to ground. The quickest way I test for a short to ground, before I even bother changing the mode of the multimeter to resistance, is I plug in a battery. Now again, this system here, let's take a quick look at this. PP bus G3 hot is powered off of these two transistors, which come from the charger. However, it's also from the battery. So this transistor over here can open, and then it sends power up here to that exact same fuse. So when the charger is plugged in, it is supplying power to the exact same part of the board where the battery is supplying power to. So I simply took a battery, I plugged it in, and after I plugged the battery in, I measured that same fuse, and I had 12 or 11.6, something like that. So the point is, if there was a short to ground, the short to ground would have been there with the battery and with the charger. So at that point, I know that I don't really have to worry about a short to ground. It's not even worth looking for. So at this point, the issue is either with one of these two transistors here, something in this part of the circuit, or with the ISL. And my guess is on the ISL, because not only is the ISL not creating power when there's no short, but the ISL is also not giving me an SMC BCA cock when everything in the system works just the way it's supposed to. So here I decide to look further. So I decided to measure, again, since I'm getting 0 point something volts over here, I decided to measure at the top of this transistor just to see if there's any power getting to it. Nothing's getting to this transistor. Now, as I say, you should simply follow the rabbit hole to try to find out what's going on. Again, if something's confusing you or you don't understand why something's not there, just measure around. Just follow the rabbit hole where it leads you. So I measure over here. I still don't have any power. Again, this is supposed to be the charging power. It says right over here, even if you don't follow it, you don't understand electronics, it says 18.5 volts, DC in, charger. You shouldn't get confused just because they take away your vowels. Vowels are free in the world of electronics. You don't have to buy them. You fill it in. I went over here. I still had no charger. Still had no charger. Still had no charger. Over here I had charger, right? Now what did I say about a transistor? What did I say about a transistor? A transistor is a resistor whose value changes based on input signal. Do not look at this whole, like, all these squiggly lines and get confused, and SGD and PN junctions. Ignore all that shit that they teach you in college because it does not help you in the real world of electronics. All it does is serve to confuse the fuck out of you. Still recording, excellent. What you need to do here, when you're looking at this circuit, is just think of the S to D as a resistor. And think of the voltage that comes in at G as controlling the resistance. So this system is not really made so that this is like a variable resistor. This is pretty much set up like a switch. Either I'm letting the charger through, or I am not letting the charger through. Now, what controls this resistor here that would open and let power through to the rest of the machine? Charger A gate. As you can see, charger A gate goes up through this resistor and goes up through here. So you have this little voltage divider over here of R7085 and R7086 that then goes to charger A gate, excuse me, which is on the ISL. So this is not, again, this is not opening because of the ISL. So my ISL is not giving me the SMC BCA cock signal, which says I should get a green light. My ISL is not providing any power even when there's not a short. My ISL is not even telling the transistors to open to let the charger through. So at this point, I'm fairly confident that it's not a waste of a chip, it's not a waste of solder, and it's not a waste of lead to replace this ISL with a new one. And when I replaced the ISL with a new one, it worked. I got my green light, but I still had 1 volt. And then I looked very close at my ISL, and I had not grabbed an ISL that was new. I had actually grabbed an ISL that I took off another bad board that had a hole in it that I accidentally put back in my bin. And when I wound up picking up a good ISL 6259, this is what I get. As you can see, I have no battery plugged in, and this is spinning just fine off of that power. Which is cool, which means I win. And that's it for today. So this is, again, me troubleshooting, no green light, no power on a board. And again, I'm going to have a different issue every time. It's going to be a different transistor, a different resistor, a different trace. There's no one answer to every single problem. And frankly, any problem that's the same thing every single time would be boring enough that even for the money, this really wouldn't be worth doing. So hopefully you learned something. If you have any comments, questions, concerns, feel free to put them in the comments field. Again, if you have questions, please put them in the comments. Don't call during business hours. I assure you, there are several people whose full-time job at 2 to 3 times minimum wage is to do nothing but make sure that nothing gets to this phone that I don't want to hear. So if you call up, again, I am very, very happy to answer your questions at my convenience when I have time if you post them on YouTube. But if you call my business phone number when I am busy doing work that's going to make me money, I am not trying to be rude. I'm just saying it how it is. I will never, ever interrupt my money work for a question. Sorry, that is just how it is. It's not to be cruel. It's not to be mean. It's because I have an... Let me show you something... Let me just give you an idea of what it is I have to work on when I get back to work tomorrow. So this is my new ticket list over here. I use a system called Repair Shopper to go through all my tickets, and these are all the things that I have to start working on tomorrow. So I have all of these. These are just the ones that are in my name. Not all the tickets that we have. Those are the ones that I have to start on. If we want to go over to the ones that everybody has to work on, then we have something that looks like this. So again, you may think to yourself, my question is only, I'm only going to take up 1 or 2 or 3 minutes of his time. But you multiply that by like a couple of hundred people, and then you add in all this crap that we have to do. And unfortunately, if I wasn't rude about it, I would just get nothing done. So, you know, don't get butthurt if you call and you ask for Lewis and Lewis is not there. Lewis is never there. Again, my staff is programmed. They are programmed to hide me from everybody. It's not them being mean. I told them this. I trained them to do this so that I can actually do my job. And that's pretty much that.